Hi, this is Pre-Algebra Lesson 3-5, Graph Proportional Relationships. In this lesson, you'll be able to use a graph to determine whether two quantities are proportional. So in order to do this, you will use a graph to recognize proportionality. You will identify a constant of proportionality from a graph, and you will interpret a point on a graph of a proportional relationship. Okay, let's start with explore it. The graph here shows the time it takes JC to print t-shirts for her school's math club. So we have number of t-shirts for the X values and time in minutes for our Y values. And we have some points. One number of t-shirt would be 5 minutes. Two numbers of t-shirts. Two t-shirts would take 10 minutes. 3, 15, 4, 20, and so on. Do you see the pattern already? We're going to use the points on the graph to complete the table. So let's complete the table first. Okay, number of t-shirts, 1, 5 minutes. And then 2 and 10, 3, 15, 4, 20. Are the quantities proportional? Are they proportional? In order to know if they're proportional, we want to figure out the constant of proportionality, y over x. 5 over 1 is 5, 10 over 2 is 5. 15 over 3 is 5, 20 over 4 is 5. Do we have a constant of proportionality? Yes. So, yes, explain the ratio of y to x is 5 to 1 over 1. Okay, so part B, start at 1, 5. As you move from one point to the next on the graph, how does the x coordinate change? How does the y coordinate change? So let's compare the change of x values in comparison to the y values. X values get bigger by 1. Y values get bigger by 5, right? So whenever you add 1 to your x value, you need to add 5 to your y values. So we can say the x coordinate increases by 1. Okay. And the y coordinate increases by 5. Let's write the points for 0 t-shirts, for 5 t-shirts as ordered pairs. Okay. Graph the points and draw the line that passes through all 6 points. So if x is 0, what would y be? If we have 0 number of t-shirts, we have no time. Like, we don't need any time, right? So we have 0, 0, and what else? If x is equal to 5, what's 20 plus 5? 25. So we got 2 points, 0, 0, and 5, 25. And let's put those extra points on the graph and draw the line that passes through all these points. Do we have a straight line? Yes, it seems like it. Okay. Suppose that after printing 4 t-shirts, it takes JC 4 minutes to change the ink cartridge. With this point, for 5 t-shirts, lie on the line you drew in part C. Okay, so after you print 4 t-shirts, she needs to change. She needs 4 minutes to change the ink cartridge, and then she could continue on. So in this case, would 5, 25 be on the same line? Well, no, because why? The y coordinate of the point for 5 t-shirts would be 20. After 20, so 4, 20 was our last point, right? But after you print 4 t-shirts, from 20 minutes, you need to add an extra 4 for changing the ink cartridge. And then you add 5 more minutes for printing the 5th one, right? Because you have 4 t-shirts, 4 shirts printing. Then this is the change of ink cartridge. Okay. And that would be the 5th shirt printing time. So no, it's not going to be on the same straight line. You have 5,29 instead of 25. So after the 4th one, you need to add 4 minutes for the ink cartridge, and then it takes 5 more minutes to print the 5th one. So you actually have 5,29 instead of 5,25, right? Yeah, so it's gonna be a different line after that. So let's describe that. No, the y coordinate of the point for 5 t-shirts would be 20 plus 4 plus 5, which is 29, not 25. 5,29 is not on the line. Okay. So this only works when we have a constant rate of change throughout the whole situation. Okay, if we have some changes in between or we need to add an extra minute, it's gonna mess up the straight line. So think about what does a graph of a proportional relationship would look like in this lesson. Look at example 1, graph to recognize a proportional relationship. Tanya exercised for 30 minutes. She noted the calories burned at 3 times during her workout. How can Tanya use this information to find how many calories she burned after 15 minutes of exercise? So she checked her watch 3 times, and later she's going to use this information to estimate the average, right? So the first time she checked was after 10 minutes. She started her exercise, 95. So that's 95 calories. After 20 minutes, 190, 30 minutes, total 285 calories burnt. And if you connect these points on the graph, you get a straight line that starts from the origin 0, 0, when she must have started, right? No time, like she didn't even start when you have 0 minutes, 0 calories. And then she starts exercising, and then this is how much calories she burned. So do we have a proportional relationship? Well, let's see if we have the same constant, right? 95 over 10 is 9.5. 190 over 20 is 9.5. 285 over 30 is 9.5. So yeah, she's burning the same calories at the same rate, right? So this is proportional. X and Y are proportional. And then we're going to use this graph to find the constant of proportionality, which means you divide your Y values and X values. But you can also get it by counting your slope. So from this point to this point, how much did you move? How much are Y values changing in terms of the X values? So every time X increases by 10, Y increases by 95. Change of Y over change of X would be your slope. So Y over X is 95 over 10 each time you move, right? So that's equal to 9.5. Tanya can use the graph and the constant proportionality to determine that she burned 142.5 calories in 15 minutes. Okay, so using this graph, she probably burned 142.5 calories in 15 minutes because that's how much calories she burned in 1 minute. So 9.5 times 15 would be 142.5. Okay. So let's look at this try question. Each 1/4 cup serving of cereal has 3 grams of protein. How can you use the graph at the right to determine whether the quantities are proportional and to find how many grams of protein are in 1 cup of the cereal? So we need to be able to graph our relationship. We have 2 constants, two variables, cups of cereal and grams of protein. And we have a ratio. Each 1/4 cup of cereal to 3 grams of protein, right? So then 1/4, 3 would be our first point, 1/4, 3. Okay, which means another 1/4, you get another 3 grams, another 1/4 cup. So 1/4 plus 1/4 is 2/4, which is 1/2. Okay, so another 1/4 and go up 3 units. That would be your next point. Your next point would be 1/2, 6. Okay, and then another 1/4 is 3/4. Then 6 plus 3 is going to be 9, and so on, right? So 1/4, 3, 1/2, 6, and 3/4, 9 would be 3 points on the line. And you can start from 0, 0, and then go through all these points. Okay, that is your line. So how many grams of protein are in 1 cup of the cereal? So we want to figure out the 1, right? 1 is another 1/4 cup added from 3/4. So you're adding proportionally 3 more grams from 9 grams, right? So what's your next point after this? It would be 1, 9 plus 3, 12. Okay, so 1 cup would need 12 grams of protein. Okay. So these are proportional. K is equal to what? Your y over x is 3 over 1/4, which is 3 times 4 over 1. So it's 12. The constant of proportionality is 12, which is K is 12. So 1 cup would have 12 grams of protein. Okay? Convince me, how can you find the constant of proportionality from the coordinates of 1 point on the graph? Okay, so first of all, what's the definition of the constant of proportionality? How do you get the constant of proportionality? The constant of proportionality is y over x. So divide the y coordinate of the point by the x coordinate of the point. And this could happen for any point except 0, 0, because you cannot divide anything by 0. Okay? All right. Let's look at example 2. Interpret the graph of a proportional relationship. The graph shows a proportional relationship between the distance and the amount of time Mr. Brown drives. Part A, what does each of these points represent in this situation? 0, 0, 1, 55, 5, 275. Okay, what do the points represent? Looking at your graph and points, you can interpret the data. First of all, you need to know what each variables represent. H represent time in hours, right? Your X is represented time in hours, okay? Y is representing distance in miles. So what does 0, 0 mean? 0 hours, 0 miles. So Mr. Brown's road trip didn't even start. So that's the starting point. Okay, starting point, which is 0 miles, 0 hours. 1,55. He drove 1 hour, which is 55 miles. So he drives 55 miles in 1 hour. And then 5,275 means he drives 275 miles in 5 hours. So if you know what they represent, you can easily interpret data using points. Part B, what is the constant of proportionality? How do you figure out constant of proportionality again? Y over X. So divide the Y coordinate with X for any point. 55 divided by 1, 275 divided by 5 is going to be 55. Okay? So yes, your constant of proportionality is 55. What equation relates the distance y and time x? How can you write an equation for this? Y is equal to kx, and k is your constant of proportionality. So y is equal to 55, x is your equation. Okay? Okay, let's look at the try question. Suppose a graph of Mr. Brown's road trip is extended. Find the ordered pair with an x coordinate of 7. What does this point represent in this situation? So if the graph is extended, right, what would 7 have? If x is 7, which point maps on this line if the graph was extended? You have 55 slope. The slope of the constant rate is 55. So 6 would have 275 plus 55, and 7 would be that plus 55. So altogether, you're adding 110 from 275, and that means you have 385. This means Mr. Brown drives how many miles? 385 miles in 7 hours. Okay, this represents hours, this represents miles, the distance traveled in miles. Example 3. Recognize graphs of proportional relationships. Explain why each graph does or does not show a proportional relationship. This is proportional because it's a straight line and it passes through the origin. So in order to be a proportional relationship in the graph, you need to start from the origin. And you need to have a constant rate of change. Okay. So even if you have a constant rate of change, okay, here we have this constant rate of change. It's a negative change, right? That's 100, or 1, 2, 3, 4, 5, 6. Every 600 of x increasing, you have y decreasing by 1, 2, 20, right? So that could be 1 over 3, right? But is this positive? No, it's decreasing. Your y is decreasing. So that should be negative. That should be negative. So you have a negative slope. But is this proportional or not? Yes, it has constant k, but if you do not start with the origin, it is not proportional. It's a straight line, but it doesn't pass through the origin, so this is not proportional. Okay? Yes, it has the ratio, but it's not proportional. And this graph obviously does not have a straight line, so this is not proportional either. Let's look at triad examples. Draw two graphs that pass through the point 2, 3. One that represents a proportional relationship and one does not. So you can graph a proportional relationship here and you can graph not proportional one here. Okay, but they both need to go through the point 2, 3, which is here, 2, 3. Okay, so can you draw a straight line that starts with origin and then it goes through this point? Yes, which would have the slope of 1, 2, 3 over 2, 3 over 2, right? So draw a straight line that connects these 2 points. That's not accurate because it also needs to go through that point as well. It needs to have the same constant rate of change. Okay. There we go. That's more accurate. Not proportional shouldn't be, you can draw an example that doesn't pass through the origin, or you can draw a non-straight line. Okay. Either way, you could start with 6 and draw a line that's passing through this point, but it's not starting from the origin. Okay, so this one could be not proportional, or you could draw another line that is not a straight line, but it goes through that point. Okay, so these are two lines that are not proportional. All right, so let's summarize our lesson. In this lesson, we learned how to graph the proportion relationship in a straight line. Your graph should go through the origin. It needs to be a straight line, which means it has the same constant rate of change, k. Okay, the constant of proportionality is 5 over here. So every time your y increases by 5, your x increases by 1. Okay, and your constant of proportionality is y over x. So that was lesson 5, graphing proportional relationships. We'll continue with the next lessons in our next video. Bye.